Just like we did with the chord theorem, knowing this tangent-secant theorem gives us the ability to solve some real-world problems. So let's take a look at a past regions problem and see how it's just, again, a matter of solving or applying the theorem and then solving the equation, although we do need to be a little bit careful when we're doing it. So in the diagram below, tangent PA and secant PBC are drawn to circle O from external point P. So we got P, we've got O as the center of our circle. O doesn't really play into the problem. If PB is equal to 4 and BC is equal to 5, what is the length of PA? And it's a multiple choice problem. So pause the video and give this a shot and then see if you can follow along with me. All right, so the way I'm thinking about this is PB is equal to 4 and BC is equal to 5, and we want to solve this for x. And so the tangent chord theorem, I'm pretty sure, says that 4 times 5 is equal to x squared. So that means that 20 is equal to x squared. And so what number times itself is equal to 20? Well, it's the square root of 20. This isn't one of the options here. And probably maybe half of you are yelling at the screen right now, telling me that I made a mistake back here. Let's think carefully about this. I did this on purpose because this is a situation that a lot of students will do is they'll set up the equation like this, but that's wrong. The tangent chord theorem says that the length of the tangent part squared is equal to the length of the two secant parts, but it's not this part and this part. It's this part, the distance from P to B, and the distance from P to the other secant intersection point. So PA squared is equal to PB times PC. All right, so this is our x squared, and PB is 4, but what is PC equal to? Well, PC, the distance from here is 4 plus 5, so it's 4 times 9. And so 4 times 9 is 36, and so a number which multiplied by itself gives us 36 is equal to 6. And so our answer to this question is 4. All right, so make sure when you're solving tangent secant problems, you don't set up the equation like this. The length of this chord is not a part of the equation. The tangent secant theorem says that the length of the tangent part times itself is equal to the distance from the intersection point to the first secant point times the distance from the intersection point to the second secant point, not the distance between the two secant intersection points. All right. So that was just me making a mistake on purpose. Hopefully that will give you some ideas on how you need to solve these problems. So when you're looking at the tangent secant theorem, make sure that you're taking a close look at the sides they give you and the sides they want for you, because especially when you're looking at that secant piece, every once in a while, they'll throw a little hitch into the problem, and you need to be on top of it so that you can make sure that you navigate that really easy pit, as long as you're keeping your eyes open for it.